Hello everyone. In this video I will show you how you can do annotation of CT scans. So for example, if you want to segment liver, heart, spleen, hips, spine on lungs, you can use our free web application that can help you do that in a minute. So in this video I will show you how to annotate 15 CT scans in 15 minutes for lungs segmentation. So the idea here is that as you can see here, our web application is very easy, very simple and user friendly, and I will show you how you can do that for the lungs, and you can see that it is the same thing for the others. So if we go to any of the tabs here, we have the same way of doing it. You just need to upload, run the inference, and download the Nifty if you want. And also you can get a small viewer here where you can visualize the output. Okay, so the idea here is that we will take some CT scans, and I don't know if you already know about our library, which is PYCAD Medic, which can help you do some pre-processing, post-processing. We are still adding new features, but there are some few features that can help you for now, and there are some libraries or some functions, modules for the conversions from Nifty to DICOM, DICOM to Nifty, Nifty to STL, and vice versa. But here I will show you how we can download some CT scans using PYCAD, for example. I will just show you the example because I have already downloaded the files, but just if you are interested of using it, otherwise you can skip this part, okay? So if you want to download some datasets, you can directly go to, I will show you the example, but you can install the PYCAD Medic by pip install PYCAD Medic, and then you can download the datasets. Let me just take one example to show you. For example, segmentation, total segmentator dataset. And let's go here, and you will see the example here. So for example, if you want to download this dataset, so from datasets, from PyCAD.dataset.segmentation.total segmentator, we have some datasets from total segmentator, we have others from Decathlon. Okay, and we are still trying to collect others from Kaggle, but yeah, these are the available datasets, and you can directly choose how many datasets you want. So we are splitting into 4 groups. We have either you download 100 scans with their segmentation, or 200, 400, or all depends to how many cases we have. So for all the datasets from total segmentator, it is about 1,225. Okay, for others it depends, but for the total segmentation dataset, all of them are 1,225. Okay, so for me, I downloaded, for example, this dataset. I will not need the segmentations because segmentation is about something else, but I will need the scans, which are here. Whenever you download the dataset, you will get 2 folders: volumes and segmentations. Okay, so for us, we don't need the segmentation, we need only the volumes, which contains here 100, it is here 98. I deleted 2 scans, but whenever you download for the 100, it should contain 100 CT scans. Okay, and if you download for 200, it will be 200, etc., etc. But if you do already have your scans, so you don't even need to see this part of the video. Okay, so the idea here, whenever we download them, the files are as Nifty, and the application here takes zipped files that contains DICOMs. So you need first to convert your Nifty to DICOM, and to do that, you can, for example, go to one of our modules. So for us, we have a module to do the conversion from Nifty to DICOM. And here is, for example, the example that I used to do the conversion for my Nifty file that I downloaded. So from PyCAD.converters, import Nifty to DICOM converter, and you just need to give the path to the inputs, path to the outputs. If you have only one file, then you can use Nifty to DICOM, then one file. If you want to download multiple files, here for us, we are having the M files, which is like multiple files. Here is the example for one file, and this one is for multiple files. So you just need to give the folder that contains the Nifties and the folder where to save the DICOMs. Okay, and here is the folder that will be created. For example, I gave the name DICOMs, and here is we'll have the DICOMs, and that contains all these. Okay, so I just download. I didn't convert all the cases. I have only 15 cases, and then I zipped them here because whenever I want to upload them to the application, the file should be zipped and not just a folder like this, okay? So now let's go to the application and start uploading the files and see how the output will look like, okay? So here is the application. We are in the lungs, so you can do the same thing for the other anatomical structures. Let's start by the first one, okay? Let's upload. So it will take a few seconds to upload. And just a reminder to give you an idea about this application, it is deployed and in a server, like very cheap server, and doesn't contain even a GPU, it is just a CPU. But even though like the inference happens in about 1 minute, 1 minute 30 seconds, and sometimes even in 30 seconds without even the 1 minute. So it depends to the scan and like the size of the scan. But yeah, I will run the inference here. For this scan, I think it will take about 1 minute, 20 seconds, but it depends to the scan. But yeah, and as I told you, it is just a CPU server and very cheap. So imagine if we deploy this application, because when I tested it in my local machine, for example, I have an RTX 3080 with the 6 GB memory of GPU, which is not like the best GPU that we can get, but it's just a laptop. So in that one, it is taking less than 20 seconds to complete the whole inference for the whole CT scan. Even for a large CT scan, it doesn't take a lot of time. So yeah, if you want to know more about the model behind, so it is a YOLO V8 model, but like slice based. It is not 3D YOLO, but 2D YOLO, but it is adapted for the scan, like for 3D scans and to get the 3D output, not 2D output. And even the model weights are like checkpoints are already available here. The data sets are available here. These ones will be available soon, but these ones are already available. You can take the checkpoints. Here is the information about the validation mean average precision, how many epochs, like the modality, like if you want to know anything about this, you can check this repository. I will leave it in the comments. And also, if you have any issue with the application or if you have any feature request, you can come to the issues here in this repository and create your issue, create your questions, ask for anything about the application, okay? And like, unfortunately, the code is not free and cannot be shared, but anything related to the application, you can use it anytime, anywhere, and for free, okay? So yeah, for example, here is the output of the first scan, and as you can see, it is very stunning output. So if you are already happy with that, you can anyways, you can download the Nifty file from here. But if you are already okay with the output, you can take it as it is. If you want to do some adjustments, then you can open it in 3D Slicer, ITK Snap, or any preferred annotation software, and you can do the editing. Sorry. Okay, so we can do the same thing for the others. Now we will run them like faster, but you can see that we can do the same thing for the 15 other scans. And in sometimes, even the scan, if it doesn't contain the lungs, you will see we will pass by one case for that. But yeah, if you are having this issue, like for now, we forget to handle this issue, but no worries. Like whenever there is no scan, there will be an error message that shows here that there is no STL path, because this visualization is an STL file, not a Nifty. So you have the Nifty, but the STL is at the backend for the visualization. But yeah, as I said, if you don't have the lungs in a specific scan, then there will be no STL files. So the issue is that you will have just an error message. You just need to ignore it and go to the next scan, okay? And yeah, let's go to the next examples and get back to that. So to go to the next example, you just need to close here so that you close the actual example, and you can go to the next one. So let's go to this one. I think this one doesn't even contain the lungs, so you can see that we will have an error message here. Let's just wait 2, 3, 5 seconds. Okay. Yeah. So this is the error message that you will get. It was my mistake that we didn't fix this, because the code is searching for the STL files which doesn't exist. So I just need to adapt this. For the moment, it is not something that will stop the application. You will just get this error. You can ignore it here, go to the next scan, okay? But whenever you get this means that there is no lungs in the scan, or if all the models couldn't find the lungs. So maybe there is a mistake by the model, but if this error pops up to you, meaning that the model doesn't find any lungs in the scan. Okay, so yeah, you just need to skip it and go to the next one, and etc, etc. Let me go to this one. Okay, let's run the inference. This one should take less than minutes, I suppose. I don't remember the exact name, the exact timing for each case, but like the total for all the 15 cases, it was about 15 minutes, which may take, like, if someone is annotating the lungs or any anatomical structure manually, it will take like per case more than 15 minutes, like per case. But for 15 cases, just like that, it is something that we need to consider. So for example, here, as you can see, it should be a partial scan, which it doesn't contain all the lungs in the scan. So it contains only a small portion of the lungs in the scan, but the model is still able to find it and segment it, as you can see here. So we can do the same thing for the 15 scans, but the video will take longer for that. But I will just show you here the outputs that we could get. I have already downloaded them. I have the outputs here for the 15 scans. So I have the STLs for you. You don't get the STLs because these are in the backend. But for me, I got them because I have already access to that. But let me just show you. And just something that I didn't mention is that I am putting in like a self-clean system in the server. So in each hour, any files are in the backend will be deleted. So no one has access to your files, only me, but I don't even access to that, like, because most of the time they are deleted before that I can see them, and for sure I don't need, or I will not see your files. But yeah, you can always ask me about that. You can, like, whenever you want. But yeah, this is a web application that is for annotation. But yeah, for the moment we are doing self-cleaning per hour, but we can decrease that like per 30 minutes or 10 minutes. But yeah, for the moment it is like that. But yeah, this is, for example, the output. This is the STL file, and these are the Nifty files. And as you can see, this is for the second one, etc, etc. And we could have all these files in 15 minutes, which is like 15 cases for 15 minutes. So yeah, this was about the video. And if you have any questions about the application, as I said, related to how many cases, or what are the checkpoints, what is the model, you can find them here in this repository. And if you face any error with the application, you can always create an issue here and let me know. Like any technical issue, you can let me know. But yeah, if for example you are interested of creating this kind of application, because this is just a small application for MVPs or for demos, and yeah, it can work, you can share it with anyone and they can use it, can test your models. But if you are looking for something like this or something bigger than this, or you are searching for a specific segmentation model for your project, you can always contact us at contact@pycad.co, and we can get back to you. We can have a quick call, you can explain your project, and maybe we can have something for you. So yeah, this is all about this video, and I hope to see you in next videos. Bye bye.